what we want to look at here is what we call simultaneous equations. And we're going to deal with simple questions in this video, but they can get much more difficult. And we want to use what we call the elimination method of solving simultaneous equations. Now, this only works for what we call linear equations, ones where we just have x to the power of 1, y to the power of 1. So we can have positive or negative numbers in front of our x and y's, but we are adding or subtracting them. So with this one here, what we want to do is find the values of x and y that allows us to find exactly what point or what set of values for x and y satisfies both these equations. Now, if we just took one equation by itself, it could have an infinite number of values that would 2 times a number plus a number would equal 6. We could get an infinite number of values. But when we pair it with another equation, what it allows us to do is to find the one value that x and y must take to make both these equations satisfy exactly the same time. So there's a couple of ways of doing this. This one's called the elimination method. So what we do here, we usually like to label our equations. So we'll label this one equation 1. We'll label this one equation 2, just because it's easy to refer to it and in our notation and be able to do this. So our aim here, we call it the elimination method because we want to eliminate one of the variables, either the x or the y in these equations. Now, we can manipulate them however we like to do that. But again, like any equation, what we do to one side, we do to the other. But this one we don't have to manipulate too much. This is why it's one of the easier ones, because all we really need to do to eliminate y is look at the situation where there's positive y and minus y. If we take the first equation and we add everything from the second equation to it. So we add 2x plus 5x, that would give us 7x. There's 2 plus 5x, 2x plus 5x gives us 7, 2 and 5, 7. But we get positive y minus y. Well, when we add those two together, that becomes 0. So we won't write anything in, but 6 plus 1 gives us 7. So there's an equation now in one variable. We've got from two variables down to one variable, and that's our aim. We want to eliminate one of the variables, either the x or the y's. The y's were the easier ones to do in this case, because we have 7x is equal to 7, so x must be equal to 1. So there's the value of x, and then we have to go and find what the y value is. So we substitute it back into one of these equations. And it doesn't matter which one, because x and y would be exactly the same in both. So what I'm going to do is take the first equation and substitute the x value back. So I get 2 lots of 1 plus y would be equal to 6. And so that'd be 2, subtract the 2 on both sides, y would have to be equal to 4. So there's our values. X is 1, y is 4. We can check it here as well. So 5 times 1 is 5, minus 4 gives us 1. So we can see that it doesn't matter which equation we put it into, it would work. Let's have a look at another example. This one with x plus 4y is equal to 7, x plus 2y is equal to 1. Again, our convention is to label the equations, so we know which ones we want to manipulate and talk about and do something with. So this time, the best way to go about this would be to eliminate the x. I don't have to do much here, because I've got an x there and an x there. But instead of adding the two equations this time, I'm going to do a subtraction. So I'm going to take the first equation and subtract the second. I could have done it the other way. It doesn't matter, because I'll get the same values. But x minus x would give us 0. 4y minus 2y minus positive 2y would give us 2y. And 7 minus 1 gives us 3. Sorry, gives us 6. We get that right, because then we divide by 2 and y would be equal to 3. We're a little bit ahead of ourselves. So y is equal to 3 there. And then sub it into any equation. I'm going to pick the second one there and to get my x value. So x plus 2y. So y is equal to 3. So substitute 3 in, is equal to 1. So x plus 6 would equal 1. Or x must be equal to negative 5. So there we go. We eliminate a variable to get an equation in one variable that we can solve, because we have to have the one variable to be able to solve equations there. Having two variables in equations doesn't work for us, and they won't allow us to do that. Once we've found one variable, substitute it back into either equation. So it doesn't matter which equation we put in, we can sub in the first one or the second one. That will give us the other variable, because there'll be an equation there with one variable in it. So it doesn't matter which way you want to go. We're going to add the equations or subtract the equations. As long as we can manipulate them to get rid of one variable, solve for the other one, and then be able to substitute it back and get our other value.